All right, so we're going to talk about surfacing, kind of the basics 101, and then rapidly accelerate, as mentioned, into more advanced techniques and ideas. So just quick about me. I'm not big on reading slides because I trust everybody here can read quite well. But I've been a designer for a while, worked in many different industries, currently work with a bunch of computer programming nerds writing software to integrate with SOLIDWORKS. So that's a lot of fun. I like to start with what is surfacing, because those of you that either work with it and don't really understand or haven't really delved into it deeply, or those that are just starting to experiment with it, surfacing is a unthickened or a non-solid body. So think of it as like a single line, like a sketch line that gets extruded. You can't measure the thickness of a sketch line. So if you took a sketch line and you extruded it out as like a thin piece of paper that has zero thickness, that's surfacing. And we'll jump between PowerPoint and SOLIDWORKS here quite a bit. But it's like this. So here is, if I try to measure this thickness, notice that I'm selecting and deselecting this on either side. It's a zero thickness body that has no depth, no Z depth to it. And of course you can do this in multiple configurations. You get the typical extrudes, sweeps, revolves, lofts, and you can kind of get contorted surfaces, which is kind of fun. But that's what surfacing is. It's zero thickness. It's just a shell of something. If you do enough of it, you can thicken it or enclose a solid volume or whatever it may be. If we jump back to PowerPoint here. Imported models will often do it. Or often a good solid body from CATIA or Inventor or Creo or whatever it might be imported into SOLIDWORKS will often get fragmented into a surface. The SOLIDWORKS can't define something, or through the translation process, if a solid gets lost, the default behavior is to go to surfaces. Because all of the surfaces that it can recognize will extract out to by surfaces, and if there's any holes in it, then it can't be a solid volume, then it just blows it apart to surfacing. And I'm guessing that's what a lot of you have to deal with. Okay. And I get a lot of questions about what's the learning curve if I haven't used surfacing and I want to use surfacing. How much is it going to be to learn? Some are very similar and some are radically different. So there's several common features as mentioned. You can extrude, sweep, loft, that type of thing. And then some are radically different, like boundary, filled, freeform, and etc. Some of the ones that are near identical, sketching is the same, sketching is sketching. The fillet chamfer command works in both environments, which is really nice. If you have a hotkey or a shortcut or everything you know about fillets in the solid world, you'll also instantly know about in the surfacing world. So that's really, really helpful and comforting from that standpoint. You got a lot of unique surfaces, or a lot of unique surface features. So here's the surfacing toolbar, kind of split into two. I recommend you add these two commands. For whatever reason, they're not on the surfacing bar by default, and I think they should be. But I find those quite helpful, so I would encourage you to add those if you really get into surfacing a lot, and we'll kind of go over what they are. I have several tips and tricks along the way, so if any of you are making notes or don't download the presentation, whatever it is, I'll mention like, hey, this is one of the best hints of the night. That's what that is. To go back through here a minute. Sorry for jumping around. So this is surfacing explained. A lot of people ask, what is surfacing good for? Why should I use it? How is it useful? You could not make this model with solid features. You can see I have a few, if we get rid of the knit and the fillet. You could not, and the power of surfacing is you can work with discrete faces. This singular face on the side of this, what we'll call in theory is a cube, I can work with this discrete face, and none of the other faces I have to worry about. I'm not defining a Z-lip, so if you're doing a loft or something, you don't have to enclose that and loft all the way through. You can just loft a single profile. This is a surface fillet looks like. The feature looks like this. So yeah, it's that cool. Anyway. So that's kind of what surfacing is. Surfacing explained is what I call this file, just because it helps explain what it is and the power and why you would use it, as opposed to traditional solid features, because there's some things you just can't design. So we've got Yeah, if you use a lot of the direct editing commands, so copy, move body, face, that kind of thing, you could also add them in the surfacing area. So surfacing, what is it good for? I get that question a lot. We just are talking about that congruently here. There's my little messed up cube. These are zebra stripes, if anyone was wondering. Here's curvature on. But like you guys all said, a lot of people use it for repairing imported geometry, modeling fixtures and working with imported geometry, assisting with solid modeling design, which we'll cover, which will be pretty fun. Creating models that aren't solid feature friendly, reverse engineering CAD data, organic surface modeling, consumer product design, and advanced C2, C3 surfacing, primarily automotive and whatnot. So here we're going to get into tips and tricks and kind of start bouncing back and forth quite a bit. Selection filters. So here's I'm going to quickly power through our surfacing features. The first few here are pretty self-explanatory, but the replace face. So here's a solid shaft that I just extruded. This is kind of where it comes in the solid model, where you want to model something in solid features, but then there's this one feature that is really difficult to do with solid modeling. If you can pull that off in surfacing, which is what I have here, this is two sketches that intersect, and then the boundary surface command, and you can get a surface that looks like that, which would just be very difficult to do with solid models. And then with the replace face command, you can say, I want the top of the cylinder, get rid of that cylinder, or get rid of that face, and replace it with the face of this surface command. And you can get a very, very nice finished face like that. So that's pretty clever. But that's using a surface to define a face in a solid, not necessarily straight up surfacing. And then we go to our next example. So this is very similar to what I'm guessing a lot of people do, at least if you're automotive based. You get a part like this, and you got to make a nest for it, right? Everybody does this? Yes and no? This is pretty simple. I really like this example because there's a few tips and tricks in here, and there's a few things that I trust everybody will learn from. So how would you guys get rid of this hole? Any ideas? If you had to do this today, how would you get rid of it? Do a surface fill and fill it in? The delete face. So right click on here, and we're going to do a delete face and make it go away like that. All right. I'm sorry. I'm putting on my lecture hat, or my professor lecture hat a little bit and trying to get audience participation. If you guys don't like that, just let me know. So the common ones are surface fill. So we're going to click on here and do fill and click there and fill it in like that, right? Who would do that? A lot of people would. Nothing wrong with that. My only thing is we have another surface in here that has split. If you put this in a CNC mill, you're going to get a dwell along there. And it's really ironic how whatever you hand off to the CNC department, almost always, wherever there is a split line here, you can see the dwell from the end mill where the G code is adjusting through the program. So ideally, we really want that to be a smooth transition. Who would do untrim? Who's familiar with untrim? We got one hand. So one person would untrim. Untrim is really powerful. If I click untrim surface, and whoever raised your hand, would you click on these edges here?
No, I usually would just pick the whole surface.
All right, awesome. So untrim edges, or untrim face, if you click on the edges, which is a little bit tricky because you think of untrimmed surface, you got to click on a surface. You can actually just pick on the edges. And SOLIDWORKS will extend the edges and close it up. So you can completely close the hole in this surface by untrimming the edges and just make the hole go away. It'll extend curvature, continuous, all of the geometry. So that's really helpful. For less picking, if I just click the entire face and choose internal edges, then it'll just go away. So whoever's done like a speaker grill for an automobile, we've got like 300 little holes in diamond crosshatch pattern in that. Who's had to fill every single hole and thought there must be a better way? Surface untrim is that better way. Powerful, powerful command. My personal favorite, however, is delete hole. If you click on an edge of any surface, or even multiple edges of continuously knit surfaces in the same body, and press the delete key, or if we can pick it here, right click and choose delete edge, it'll give you an option: delete the feature, which would be the surface offset, or delete the holes, and it'll basically perform a surface untrim for you in a delete hole functionality. My frustration about this particular feature is it's not very well documented and you cannot find it. If you search for commands and look for hole, it does not exist. The only way to find that particular command is to literally find a hole and right click on it, or find a hole, click on the edge and hit the delete key. Okay? I showed this to a customer several years ago, and they're like, that is amazing. That will save so much time, because they had holes all over the part, and instead of adding multiple features. So they would use the delete hole. And I came back like a year later, and I look at one of their models, and they had like 300 delete holes all in order, because they had 300 holes to delete, or whatever the example was. And I was like, why are you doing that? And they're like, well, we hit the delete hole, we complete the feature, and then the command goes away. You can't multi-select anything. Second tip of the night, or third, whatever we're on. After you delete the hole, and I'll do this again here in a minute. So we click on an edge of a face, hit the delete key, and again, this only works in surface scene. If this was a solid hole, you'd get a radically different result. And click delete hole, the feature goes away and the hole gets deleted. But if you go back and you edit the feature, now you can pick more than one hole. So it's not available in the beginning. You have to go back and edit and then do a multi-select, and you can delete as many holes as SolidWorks will let you delete. It has some limitations. So if you're using the delete hole command, just be cognizant of how many holes you're deleting and go back and edit it. It's kind of one of those commands that nobody knows about because it's hidden, and then features inside the command of the hidden command that nobody knew that existed that saves a lot of time. So I have a delete hole in there. The next thing is I need these, because of the small radius on the part, I need this surface to get taller so that I can have my nest fully encapsulate my part. How would you make those surfaces taller? What command would you guys use? Extend, yep, that's a great command. Some people would also use untrimmed surface. You can even do a ruled surface and try to extend it if you're trying to do, out or chamfer or whatever it might be. So I agree with you. I want to do the extend surface command. So in the extend surface command, you pick on the edges, and it'll extend the surface. It basically does a curvature continuous. And it'll take the existing surface that's there and then stretch it out, following the same curvature and body or shape of the body. However, you notice I didn't extend these two sections. So if I click the tangent line here, the tangent connector, it'll grab that there. But it fails. I get this question a lot if I'm running tech support or doing consulting. They say, you got to come over and teach us how to do surfacing. Okay, sure, no problem. I'll come over. Nope. What do we want to learn? Well, we are using the tips and tricks that you told us last time, and we're doing a surface extend, and we just can't get it to work. So I come over and I look at what they're doing, and like, yep, that should work. No question, that should work. I should be able to click on this surface here, or that edge, and I should be able to extend all of that. SolidWorks, however, just disagrees and says you can't extend that. So on this particular model, for whatever reason that I cannot explain, you can only extend those surfaces with that one command. However, if you do the exact same command a second time, you can extend the other surfaces. You just can't do them all together. And this probably goes back to the person in the back who said that they weren't in love with it. This is the #1 complaint about surfacing in any CAD package. SolidWorks is not the only one. The complaint is it's inconsistent and you have no idea what it's going to do. I do not disagree. It is one of the biggest frustrations. Surfacing is just weird. So a lot of times, if it doesn't work, if it's not doing what it should be doing, just back off a little bit. Don't pick as many things. Break it up into different features and scale back the operation that you're trying to do and use multiple features. A lot of times you become successful in what the task you're trying to accomplish. The next tip and trick here is I want to extract the surface off the bottom of this part as the top plane for my nest. How would you guys do that? Any ideas? I'm sorry, what?
Move face.
So move face would take the face and move it up or down, but it's not going to extract it.
Offset surface.
Yep, so this is a solid body, and I want a surface on the top of that, but I want it to match. And because it's a curved part, I just can't like easily extrude one. You were saying offset surface. Yep, so offset surface is a great command. If I select on it and find my offset command, I can specify a distance, including 0, which there's not very many features in SolidWorks you can define 0 on. So a lot of times people don't connect, I can offset something 0, because what it's actually doing is it's just extracting that one face away from the solid body. So offset 0 does work. However, if you are trying to extract a face without offsetting anything, there's a different command that I favor even more. If you knit, so everybody's familiar with surface knit, right? But if you knit a face off a solid body, it'll extract it as 0 thickness. Yeah, it's really weird, but I really like this command much better because the surface offset command is going to go through a fairly lengthy computation to try to figure out what the offset is. And it's also a little bit more dangerous because if somebody else does it, or you touch on, or if you have Instant 3D enabled and you actually change the 0 to 1 or something like that, you get really disastrous results. So surface knit will do a guaranteed 0 offset of a face on a solid body. And it's a very fast command. If you have to pick a lot of faces, the surface knit will calculate that much faster than an offset will. And then you get a 0 offset surface body on your solid part. So that's super cool. So here's the untrim command that I was just talking about. I just picked on the face and clicked external. They have a percentage here, which is kind of funny because it shows a dimension, but what you type in isn't an actual dimension, it's a percentage of the original body. So don't get confused on that either. But you just type in a percentage and it'll just grow that surface in its natural curvature continuous form. So you can kind of see here it's curved both directions. So that'd be a difficult thing to reproduce accurately. Okay, what did I do here? So surface trim. I hope everybody or anybody that does surfacing a lot should be familiar with this. But if you have two surfaces that intersect, if you pick surface trim and select your mutual command, you can select the surfaces that you want to trim. Then you can select the sections that you either want to keep or remove. My rule of thumb here on the keep and remove is just whatever's less. If you got two surfaces that interact and you have to click 10 times to keep them all, or you have to click 2 times to remove them all, just remove them. In this particular example, it's a wash. I got to click twice either time. But just be cognizant that you can either keep what you select or remove what you select. So just do whatever is easiest. There's really no advantage one way or another. So then here I just extruded a solid block up to that surface body, which then formed my nest. Because my original command was an offset to give me my distance. So here's my nest like so. Couple other things real quick in here. So I cut the top of that nest down to create it flat and even, so I can very easily put it in a CNC machine and or a vise, so I can CNC machine it, because it wasn't critical that the top of my nest be curved. And then I have, who's ever used delete face? All right, a good healthy number of people. How many times has delete face failed on you? Once. Okay. So this is another really interesting one of, should it work? What am I doing wrong? Again, I get a customer call and says, I'm trying to use delete face as you demoed to us, or as you taught us, and it's not working. So they email me the file, we go to GoToMeeting, or I go over there, or whatever it is, and they show me, and they're like, yep, I picked this, and I picked this, and what delete face does, we'll show it to you this way first. Delete face will just simply delete the face. So notice here I can look through my model. This was a solid model. If I roll this back, you can see how I have a solid model here, or solid body, I should say. And then as soon as I do a delete face, it gets exploded into a surface body because it's no longer watertight. There are places of the surface that are, or faces on the body that are no longer there, that need to be there for watertight. So a delete face with the option of delete, which seems to be a given, will just simply blow the face away, and if it's a solid, turn it into a surface. If it's a surface, it's just a surface. Delete and patch will actually delete, and I'll kind of show you this. It'll actually delete that and run an untrim command at 0 on the two or more faces that you're interacting with, and then basically untrim it all together. So you can see I had a hole there, I hit delete and then untrimmed all the sides and then trimmed them together so that divot just disappears. But instead of having to delete it and untrim it yourself, you can actually run a delete command and choose delete and patch, which is basically delete and untrim and then knit back together and form solid. So here is what it looks like, where you have before the delete face with patch and then after the delete face with patch. So it just gets rid of that divot. And like all the other commands, you can do multi-select. So I want to get rid of these two divots. So I say delete and patch, and it won't. It just errors out on you. And this should work. And for whatever reason, SolidWorks will fail on this particular selection of this particular command. So same thing. You just have to run 2 of them. Command's not broken. You're not doing anything wrong. Just lessen your selection and see if it'll calculate after that. And then typical holes and fillets to make it look nice. Come back here. All right, there you go. So just rest of it is solid features that we should all be familiar with. So there's some tips and tricks on knitting, untrimming, trimming, delete face, delete hole, etc. Anybody have any questions on this or anything else you want to add? Yes, sir, in the back.
How does delete and fill or delete and patch differ from delete and fill?
Excellent question. I think I have a slide somewhere later, but this is just as good of a time ever to talk about it. So delete and fill will actually run a delete command like this, and then it will run a surface fill command, and you basically end up with what looks like the exact same geometry. A delete and patch will do an untrim. So, and we'll talk about this later because I don't necessarily like this particular option. Delete that. Because when you delete fill, you have one option, which is tangent fill and then show preview. If I'm going to run a fill command, I want to use the fill feature because I have infinite more control. And then I'm looking through my feature tree, I'm like, oh, I deleted out geometry, and then I filled geometry back in, as opposed to it all hidden inside of one feature. But the delete and fill doesn't untrim anything or doesn't blend anything together. It just replaces the faces, the face or faces that you deleted with a filled face. Does that make sense?
I understand what you're saying. I just don't see what I agree I wouldn't use that command because it doesn't seem like it accomplishes anything.
Well, in the slide that I have later, in the demo models I have later, I'll show you where it is quite beneficial.
Okay.
Anyone else have questions or comments on this particular model or example? Am I going too fast, too slow? Can everybody hear me? Okay. I love surfacing, so as Peggy said, I could talk about this for a while. All right, so this is a really fun one. You notice I use the same part a lot. It's a good demo file. So this is where the delete and fill is really handy. I have these fragmented surfaces that I don't like. This is really bad machine, really bad design. Every time I interact with a surface, I gotta click 5 times instead of 1. It's gonna just make for a poor model. So I just wanna right click and delete and fill. Tangency is fine. I can pick all those faces, green check. And, well, that wasn't what I wanted to do, but I thought it would have filled it in. That must be somewhere else. But anyway. We all agree we want to clean this up, right? This is not a good model to go into production. I do not want to use this in my nest or anything else. So I'm just going to right click here and delete and just blow all these away. I don't want them anymore. And then what would we do? How would we get this geometry back?
Boundary surface?
Boundary surface is an excellent suggestion. So we pick boundary surface, and then we want to select this edge and this edge, right? Oh, but darn it. Now I've got this little fragmented edge selection, and I'm not going to get a nice continuous surface. How do we solve that problem?
Selection manager.
This guy is on top of it. Who knows what the selection manager is? Again, little frustration. It's kind of one of those hidden commands off in the back that's not very well documented that like only the super awesome power users know about. And that's why we have user groups to spread the love. So if you right click off into space, I think you can right click kind of on anything, or even a lot of people right click in here. There's what we call a selection manager. And it will allow you to select multiple things that only count as a single selection inside of the feature. So the option we're going to be using today is mostly going to be the select group, but there's also select closed loop, and then select open loop, select group, and select region. But select group is what we want. But basically here I can go click, and then the little tangent command is super helpful. But in this instance, excuse me, to prove a point, I'm going to click twice, and we'll click more than that. So then I can say green check, and then you can see here in the selection manager, instead of having just a single edge, I have an open group, which is the sum of those two edges that I picked through the selection manager. So then in direction 2, I need to pick these edges down here. So I see that my edge is fragmented here already, because I can't pick it all at once. So I'm going to right click, selection manager, and then click and click and click. And that's good. And then selection manager again, and pick those 3 edges. All right? Everybody's happy with that, right? We can do tangency, because of course this is an automotive part, so everything is tangent, or you could pick or you could pick curvature, and there's other options you can pick. But we're all happy with that, right? We started with this, we ended up with that. Okay, who's good with that design? We got some hands. Who's not good with that? Why are you guys not raising your hand? Either you don't care about any of this, or what would you do different? I'm sorry? Any other ideas? Okay, so my really big concern with this is, how do I know that the geometry I put back into this model is representative of the geometry that was given to me? I am changing customer data before I cut a nest to it. And I have no guarantee that this is accurate to what was given to me. Who else does that scare the crap out of? Who else has had to recut nests because you didn't think about that and totally messed it up and your boss yelled at you? Really? I'm the only one? All right, whatever. I don't know why you guys aren't up here presenting then. Gosh. So the other way, and what I often get, is a filled surface, right? I can click filled surface, and then I can pick all of these edges, select and select, and for whatever reason I don't get the tangency here, which is kind of irritating, but I can pick all of these edges. Okay, so who gets the point? And then SOLIDWORKS will fill this surface in. It'll say, here's my boundary, and let's overlay a filled surface. This is kind of nice because I can apply up to all, and I can say I want every single contact with my old part to be tangent, and apply to all, green check, and it fills this in. Okay, it gave me a couple fragmentations here because of my multi-pick, but that's another option. But again, I have no guarantee that the geometry is the same as what I just removed, which is very, very detrimental if you're trying to cut accurate nesting on a part that you don't have physical access to. In the instance of this, one of the tips and tricks, going back to my PowerPoint, is right-click menu, select tangency, open loop, and all that. Instead of all that clicking, I can right-click before or after my feature. I can right-click and select open loop and pick all of those instantaneously. Who knew about that? 2 people. So everybody else here didn't know about that. You learned something, right? Awesome. I did my job, Peggy. So I can right-click and pick. It's really fun because you can right-click and pick tangency, which will just pick tangent of that selection. And then there's open tangency, which means, and I've got another model for this, but it'll stop as soon as you have an open contour. It won't go through the rest of the part. And then there's loop, and then there's open loop. So loop, you can see here, it went around this particular face. And then open loop follows the open contour of what you're trying to fill in. And you can pick all of that before or after the surface fill command. So I can pick the surface fill command, right click, open loop, and you're done. Green check, and you're done. Super awesome. One of the other hidden commands that I recommend you add to your toolbar, if we go back 2 slides, is heal edges. Who has ever heard of heal edges? 2 people. 3 people? All right. Heal edges, again, another one of my mild frustrations is that its exclusive sole purpose is inside of the surfacing environment. Yet it's not added to the surfacing toolbar by default, and nobody knows it exists. What heal edges does is you can pick on edges that have open edges, or you can pick on faces that have open edges like this, and click heal, and it will reduce the number of edge segment selections you have to select. So notice here it went from 850 to 845. If I green check on that, I now have single continuous edges that I can pick on simply 4 times. Okay? That's awesome, guys. Come on. It is. It's super awesome. And there's no limit on selection. So I can literally pick hundreds of faces, heal edges, and reduce possibly, I've had it before, hundreds of line segmented selections, which makes the rest of your model so much easier to work with. So I probably should have showed that first before I showed the right click and select open loop. The right click and select open loop is a last case, last chance, like I've just got a lot of stuff to select. But start healing your edges, because now that my edges are healed, if I right click and select open loop and surface fill, I won't get those fragmentation pull lines because I didn't have that fragmented surface or fragmented edge selection. Right? Everybody with me so far? Okay, awesome. But I'm still really nervous that I did not replace the geometry equivalent to the geometry given to me by a customer. That's still a serious concern, right? Everybody's with me on this, okay. I really like nodding heads. My class learns that about me really quickly. Because if they're not nodding their head, then I start asking them questions. So here's probably one of my most favorite tips and tricks that I hope everybody will walk out here remembering. If you, you got to go 3D sketch points, put points in 3D space. So again, these are in 3D space, not on a plane, attached to the surface that you delete. And then you delete your surface. And then you heal you would heal your edges in there somewhere. But then if you pick a, whoops, hang on a minute, I'm forgetting my own demo files. And then you pick your, well, let's heal edges a minute. Oh, another tip and trick with heal edges, you have to click the heal edges button. This is also kind of frustrating. If I pick my faces and just hit green check, it sometimes doesn't work. It might have been a bug or they may have improved the functionality, but always click the heal edges button. Otherwise, it doesn't always heal the edges. Again, I don't know why. You'll have to find somebody that works for SolidWorks and ask them. But now if I do a surface fill, I can right click, select open loop on constraint curves. And again, kind of a misnomer, mislabeling here. Everybody thinks constraint curves, I have to pick a curve. But in reality, I can pick a selection of points from a sketch. And now I have taken this face and either pushed or pulled it, but I've constrained the face to a selection of points in 3D space that were connected to the old face that I just deleted. So now I have very, very good assurance, at least on simple geometry like this. You can't delete half of a part and try to pull this off. But I now have very good assurance that I'm matching the geometry of the part that my customer gave me. And green check. And now I have a different model. I don't have it here evidently. But where I do this and I overlay all the faces on top of each other. If you just do a boundary face or a surface fill without those constraint points, it's several thousands off. And if you do the constraint points, it's just exactly right on. So that would be my most significant tip that has saved me the most hassle throughout my design career, of the 3D points in space doing your constraints. And now I think I really messed up my demo model, so let's reload this quick a minute. And I think I basically just did the same thing around, yeah. So I just used that to repair my other faces, is what it was. Oh, here it is. So these 3 faces here, so here's my one. All right, so here is 3 different features filling that same gap of the delete face. This is the surface tangent, and let me try to change this color here a minute. Surface tangent will be green, or the surface fill with the tangent option. The loft, we'll make that, evidently a lot of things are turning green. Yeah, that's a problem. Oh, it's because I picked the part. It'd help if I not picked the part. Sometimes coloring can get a little weird in surfacing. But anyway, you guys can download these models too. But if you compare them next to each other, you can see the amount of deviation, and I can't get the colors to come through. But you can see there's going to be deviation between the different features and how it's selected, and the one with the points is going to be the most accurate to the original geometry. All right, moving on. So this is your delete face and fill. So whoever asked the question there in the back, this is the excellent. This is where I would use it. So this is where we have a delete face that spans multiple faces. So I don't want this block sticking out here on this downloaded cone gearbox for whatever reason. So I can pick all of these faces, even though it spans multiple surfaces. And if I select patch, it will just close. It'll knit all the surfaces together and trim them all up. If I was to select fill, all those faces would go. Well, this one's going to fail, but all the faces would go away, and I would just overlay a face that just filled in the middle there. I've got that example over here. So if I want all of these to go away, I can pick multiple faces and select fill, and you get a result that looks like this. So it just is going to overlay one face on top of everything else and fill in the open void. So that's that. I think I can just delete more of those two, I believe. Yep, and well, I've got this face that scoots underneath there, but it'll fill all that in. What I'm demonstrating here is I don't really like that command. I would much rather just plain delete my faces, and then I would rather launch a surface fill command where I can have control over curvature, continuous, constraint curves, a lot more control here. And then that way in my feature tree, I see I deleted something, I see I filled something. I don't have to go into a feature to look at the options of the command. Does that make sense? Personal preference, but that's what I would do there. So this is really just to cover the freeform feature. I'm not really a huge fan of this, mostly because when I use SOLIDWORKS, I like to have control and hard inputs, and this doesn't really let you do that. But basically, you have to pick an existing surface, you have to lay down these control lines, and then you pick randomly in space to add a point. So I just kind of click. There's no way to place these accurately. So with these grids, you kind of just say, I think I want it there. And then after you place that random thing in space, you can then drag it around. Now I can accurately place my point in space because I have my triad here. So I can say, I want this point that I randomly put in space in this exact spot. But it's going to pull that face over, and you have no idea where you placed it and where it's going to end up. Or based on where you placed it, you know where it's going to end up, but you don't know what the effect is going to have. So this is really a freeform, exactly what it is. It's freeform. If it looks nice on the screen, then you better be happy with it because that's what you're going to get. So I designed this model quite a while ago for some person that wanted some fancy sink in their house. So then here I put a surface on there and then mutually trim those together to put a flat for the drain. Filleted that in. So again, like I was saying earlier, the fillet command is very consistent. If you know how to use it today, you know how to use it tomorrow in surfacing. This is a surface body. There is no thickness here whatsoever. I can launch my fillet, put it in there. It'll work perfectly fine. So that's very comforting. Extended a flat off the back there for the water faucet and stuff, and put some edges on there and then thickened it. So this is kind of a sheet metal that you can't flatten because it can't flatten some of this geometry and that freeform. That'd have to be English wheeled or deep drawn or something like that. But that's a kind of cool looking sink. And then the flatten feature, I think, is my last example on this set. The flatten feature is also kind of unique. I'm not entirely sure what it's good for or what its targeted use is. It flattens the surface without a hole. So notice here I used the thicken command or the knit command to extract the surface. Then I used surface untrim just to show you how that works. I could have used the delete hole as well. Should have used the delete hole. And then you can flatten it. The surface flatten is you pick a surface, you pick a vertex, and you say flatten. You have no control over it. You have no material definition. You can't say this is leather or this is sheet metal or this is anything. It just flattens it somehow, some way, and the answer is just whatever it is. It doesn't let you flatten stuff with holes in it, which is why I had to do my untrim, because now the flatten is going to error out because there's a hole in it. I'm told SOLIDWORKS 2016 will let you do it with holes. I'm running my demo in 15, so if anybody hasn't upgraded to 16 yet, you can still download my files and use them. You're welcome. But it won't let you do it with holes in it. 16, I believe, will. Also, you can just adjust the accuracy, which I'm not quite sure what you're adjusting the accuracy on, considering we don't know if the output is any good based on the lack of inputs that you can give it, and it doesn't know what it's... I don't know what it's doing as far as what the stretch and yield and stuff is. So, yeah. Also, the feature is only available in premium. I think it's a premium only feature. So it's like this random feature in your surfacing tool set that if you have a premium license, you can use. If you have a standard license, you can't. Or standard or professional, you can't. I don't know. Like I said, you'll have to find somebody at SOLIDWORKS and ask them. Anywho, so that's my first set. We'll go back to PowerPoint here, see what else we got. Yeah, so again, lots of tips and tricks here, different things to keep in mind. The heel edges and selection filters is really the big thing in this particular tips and tricks section. Oh, this is kind of another funny thing, is that if you have a surface body, so here, if you have a surface body and you're like sketching on something, so who's done this before, right? You're sketching and you're drawing stuff and you're like, oh, I don't want any of this, so I'm just gonna box select and highlight everything on my sketch, right? You cannot drag and drop box select anything while sketching while on top of a surface. If you start outside of the surface, it'll work. But if you click on a surface to box select something, it just doesn't do anything. So like if I want to make these two circles equal, I have to start out here and start out here and box select left to right, so I only select entities that are inside, not just intersecting the rectangle, and then I can make them equal. So just one of those things that can really frustrate you if you're not entirely certain what's going on because your box select doesn't work. Also, Control A would, work the same thing. Whoops, wrong button. There we go. Heel edges. If the feature isn't building, it's not you. Just try something different. I mean, it might be you, in honesty, but it often isn't you. I got to be a little clear on that because you can't just do whatever. Check bodies. So this is a fun one. This has also saved me quite a bit of time in times past. How to check bodies for errors, or for surfaces, I'm sorry. So who's gotten this, where you open up something and you're like, it's an assembly. And I wonder how many surfaces are in here, right? Who's gotten this? And you're like, all right, well, let's open apart. Oh, it's an imported body. Good. Let's open apart. Oh, yeah, that's an imported body too. Good. Who's ever done that? Because you got, the company rule is you can't put something in the EPDM with surfaces or whatever it might be. Who wants to know, the easiest way in the world to check an assembly for surface bodies? Okay, this is awesome. I should get my PhD for this. Not really. If you do a cut extrude in a assembly, we all know cut extrudes only affect bodies. A cut extrude will not cut anything away from a surface ever, ever, ever. You have to use surface trim, that type of thing. So if I do a cut extrude in an assembly and just blow everything away, what's left are surfaces. You can find anything instantaneously by doing a cut extrude in an assembly. FYI. Another really good hint. So if you are who gets a body in that has a whole bunch of errors on it, and you start repairing the surfaces and fixing stuff up because the import diagnostics doesn't work really at all. Okay, maybe they've improved it. I've not come to trust it, but anyway. But you get halfway through your repair model, and then it's not knitting. You can't form a solid out of it. You don't know what's wrong, but the import diagnostics doesn't work anymore because you've got features below your original import. Who runs into that? How do you get around that?
I save it as a parasolid.
There you go. This man's on top of it.
Back in.
Yep. So you save it, you step it out, parasolid out, IGES it out, whatever it might be. Parasolid is the best option. And then re-import it and rerun your import diagnostics, figure out what's wrong, go back to your original model and keep fixing it. So you have to have a blank feature tree, except for the imported body, to run import diagnostics. And to do that, you just round trip your model in a parasolid. You can figure out what you need to keep working on, go back to your original model and keep working on it. So that's a really great tip, which sounds like you've been using for a while.
A lot.
So we talked about the delete hole. Okay, so it looks like I'm through my PowerPoint, so I'm just going to power through some more models here. Data import. Okay, so this is a fun one. Customer called me up the other day, called me over, I should say, and said, we have an imported model and I cannot get it to solid. We need it to be a solid because I got to put other holes in it and stuff. Because if I put this in EPDM and Peggy or somebody else, we're working on a design together, and they need to, add holes to this. If they insert a sketch and, do a cut extrude and like, I want to cut extrude through there, well, it's just not going to work because those are surfaces. You can't cut extrude through surfaces. So company standard has got to be a solid. And somebody called, or a customer said, I can't figure this out the other day. And what they were doing is they were figuring out, I think this is Inventor. I believe Inventor will allow sheet metal to be formed up and touch. In SOLIDWORKS, this is zero thickness geometry and it won't allow it. So SOLIDWORKS says this cannot happen. So when in the import process, it blows it away to surfaces because you can do whatever you want in surfaces. So they're saying, I'm trying to remove this. So we do trim mutual. We're going to pick this. And we're going to pick this surface here, and we're going to remove this and that. Right? Everybody with me? So the trim feature is going to remove the extra geometry that I put in there, cut that away, and it's going to remove that bent flange in the sheet metal that's touching, and then this should work, right? This feature should rebuild. Everybody agree, right? The problem is what the SOLIDWORKS trim surface feature does in the back end is it automatically knits the model together. You have no control over this. There is no option. It's going to happen. And so when it tries to knit the model together, it will fail because there's other things that are still touching that are still zero thickness. So then my customer's like, oh yeah, okay, I get that. So then let's do a, and you can see how long some of the surfacing stuff takes to think. It's kind of a bear. So they basically drew 4 of these little things on all 4 corners and tried to do it, and it still wouldn't work because without realizing it immediately, this entire thing is one huge surface model, which means it was also trying to knit these corners, knit these corners, which were also touching. So to get it to work properly, once we figured that out, you had to draw that around all 8 corners, cut all 8 corners away at once, knit that entire thing together all at once, and then we could thicken it and create a solid. But if you couldn't find all 8 corners, you would play with it forever. So I didn't really do it in this model here, but my next tip would be cut your model in half, or quarters, or tenths, or whatever. You can just draw a line and split a model, cut it apart, and then you can fix just one little area, figure out what works, and then move on to the next area, move on to the next area, move on to the next area. If you don't know everything that's wrong, it can be really frustrating. Also, how, I don't remember if I have one, maybe here? Nope. All right, so here is a cone gearbox, I think, that I repaired for somebody a while back. And so after I got everything repaired, we got to knit it all together, right? So we knit everything together. We pick all the faces, fill all the gaps, all the surfaces, all the gaps. And so now I just have a single surface body, right? How many of you, when you would knit something like this, how many of you pick the try to form solid option? Which I don't know why this doesn't even let me do it. I thought it would. But anyway, how many of you pick the try to form solid? So you knit all your surfaces together, then you create a solid model. Right? Several of you? All right. And this varies. Your mileage may vary based on what type of surface modeling you get into. But I strongly discourage using that checkbox. It's an option and a feature that I wish they would kind of get rid of. The reason being is because any solid modeling features you do after, if you do cuts, holes, extrudes, fillets, whatever it might be, the immediate parent of all of those features is that single knit. Right? Everybody gets parent-child relationships. That knit creates the solid. Any solid features are all childs of that knit. That knit command will fail if anything upstream goes foobar. Now, if you're repairing something like this, it's usually not a big deal. But if you're doing any type of a nest fixture, machine design, organic surface, or fiberglass or consumer product part modeling design, you're always going back and tweaking something, changing something, and your knits fail all the time, right? Anybody that's working in that environment, you have knits fail all the time, right? With changes upstream. Yes? No? Maybe? Okay. When that knit fails, if you go edit something above, that knit often gets deleted. Often that knit shows up in your delete confirmation dialog, and you can't uncheck it. It's a consumed feature that SOLIDWORKS requires will be deleted, or you can't delete your other part or your other feature. And same thing with suppression. If I delete another feature, that knit will be suppressed. So that's really frustrating. So I don't like the create solid body as knits. I like the more proper separation of concern, let your knit surfaces. And then another tip and trick, the thicken command. If you choose an enclosed volume, a option that isn't otherwise there appears that will allow you to create a solid from enclosed volume. How many of you guys have used thicken to just like take a surface model and make it like basically sheet metal? Right? We've all done that. How many of you knew that if you picked an enclosed volume, it would create a solid from that enclosed volume instead of just thickening like sheet metal? Awesome. So the guys that do this know that.
Sometimes it works, sometimes it doesn't. I've used the knit because this just said no.
Okay.
Any idea why the knit would work when select from enclosed or using the enclosed volume didn't?
I don't know. The question is, for sake of the recording, the question is sometimes the thicken create solid from enclosed volume fails when the knit create solid body or try to create solid body works. I don't have an answer for that. I have to see the model and play with it. Again, I would just say it's SOLIDWORKS. Surfacing is weird. I don't know. I'm sure you're doing nothing wrong. The other thing, I gave this presentation in Holland, and one of the SOLIDWORKS AEs, or DESI AEs rather, happened to mention that he also gets very nervous anytime SOLIDWORKS calls a feature try to do something. He's like, I'm not a big fan on trying to do something. I'd like to rather just do it. So he said personally he always shied away from features that tried to do something.
Well, that always tells me if there's a hole in there. It won't do it if there's a hole somewhere.
Well, right, neither of them will do it if there's a hole somewhere. That's going to be consistent.
Okay.
Because if there's a hole somewhere, the thicken command will say, it won't give you the try to enclosed or create solid body from enclosed volume. If there's any kind of a hole, that option just isn't there at all, and it'll just try to thicken it like sheet metal. So either way, that'll accomplish. So then I combined, because this one was a solid already, and then cut that shaft through because it needed to be done. Anyway, my advice would be, from a parent-child relationship standpoint, especially if you're doing more consumer product surface design type thing, when you're going up and modifying your tree and dimensions and whatnot, your knits will often fail. And then if you have try to create solid volume, then your downstream features will fail on top of that because they're children. So try to have an isolated feature, because now these here, the parent is going to be the thicken. So like this here, the parent will be the thicken. And then as long as you can maintain that thicken, the thicken may error and all your features below it will error. But you can delete your knit, fix your tree, introduce a new knit, and then re-thicken, and then the rest of your features usually have a higher chance of rebuilding if their parent is thicken and not knit. So fairly lengthy. I didn't mean to dwell on that for that long, but that was that. Anybody have any questions so far? I should probably have been asking more. Yes?
I just wanted to add one thing to the knit.
Yes.
I'm not sure if you mentioned it, but sometimes the knit doesn't knit every surface and we can change the gap tolerance
Yes.
and that solves the issue.
Yeah, excellent point. I did not mention that at all. Thanks for bringing that up. In SolidWorks 2013, 14, 2012, something around that era, they introduced this gap control command, which basically analyzes the model, finds surface edges that are so far apart, and it says, hey, do you just want to close this gap? The old knit command, I think, did it automatically to a limited degree, but that gap tolerance was fixed, and you didn't really have control or visibility over it. So now they let you see it, and then they let you control it. The largest gap they'll let you do is about 30 thousandths, or nope, yeah, about 40 thousandths, give or take. But you can show all gaps between a atoms level and 40 thousandths. And then you can, and they kind of check or all uncheck, which I find kind of odd. You'd think I could pick and choose, but it does them all for you or none of them. And then that will again, it will kind of trim and extend surface. It kind of twists them a little bit. If you have really big gaps, like 40,000 gaps, I would maybe go back and fix it manually, because some of that automatic gap fill gets really weird. It'll just like pull it down and contort your model. But anyway. But yeah, good point. Thanks for bringing that up. Gap control is very helpful when properly utilized. Any other questions or comments anybody wants to bring up? Okay. On to the next segment. We have... Oh, we just did that. Solid modeling assist. So this was the original idea. Bring it up now that we covered surfacing a little bit more. The boundary surface is really cool. This came out again, I think, in 08 or 09 or something. It's been around for a while. But before in surfacing, you would have had to make probably 6 sketches. One that would be the far left-hand side, the far right-hand side, and one in the middle if you're doing any type of a transition. And same thing here. And when they introduced the boundary surface, they kind of introduced the boundary surface with the goal to replace the loft surface, because it kind of does everything the loft does and gives you more control and has more flexibility. But the really cool tip and trick with the boundary surface is if you pick a single direction 1 and a single direction 2, and if they intersect, you can create very, very cool surface geometry like this with just 2 sketches. This before was kind of not possible at all, without a lot more sketches and a lot more finagling. And then, of course, we talked about already the replace face. I can just pick that surface face, and then I can pick the face of my cylinder here, and then we can extend and cut and trim and do everything that we would normally otherwise do. And extrude up to face would also work, but this works well if you're trying to work with imported geometry, or this is multiple extrudes. So you can just extrude it all to some arbitrary level and then replace face. Any questions on that? So here's that was what I would call a solid modeling assist, where I'm going to do all of my features in solid models, and then I just need surfacing to do something a little bit more complex, but I don't want to do surfacing, design from a model standpoint. This is another similar example. I was tinkering around with a pistol frame design a while back, and I wanted this radius here for your grip to be different than the radius back here for your back strap, or your beaver tail, whatever they call it. And so I laid a couple surfaces in here. We can see them like so. And then I put a boundary surface between the two. So you can see this would be very difficult to do with solid sweeps or solid lofts. Because if I'm going to sweep this, I have to define my z-axis, as we're calling it. I would have to draw something that comes up to here to create an enclosed volume. But I'm going into such a small space in the corner here that that's kind of difficult to pull off, because that other distance then tends to self-intersect when I sweep that corner. And then the loft is kind of weird, because the loft is pulled and contorted based on the other 3 sides that I could care less about. The only thing that I want to loft over, which I used the boundary surface here, which is the replacement of the loft. The only thing I want to loft over is this one face. If I had a sketch that kind of came over here, I would only be lofting that like maybe a 1/4 inch, and on the other side I'm lofting like 1 inch. And so you'd get a very weird loft on the other side, because the 1/4 inch and the edges are constraining that loft to try to keep it uniform and consistent. I mean, that's just how lofting works. So in this instance, I was able to use surfacing and very, very effectively blend this larger radius, or smaller radius, to this larger radius, and then sweep that over. So I knit that together, and then the next feature I want to talk about here is the surface cut. If you ever have a surface that interacts with a solid body, you can use a surface cut, and the command inputs here are really hard. I offer a 3-day class on this. It's $9.99. You pick a surface, you pick a direction, and you hit green check. So that's that. Well, yeah, there's always that. The only time I've really had issues with this is where the surface did not fully split the solid model. If you're 1/1000th off somewhere in one corner, it'll absolutely freak out on you. So if you're ever cutting with surface, make sure your surface is totally covering your solid bodies. And I've personally never had an issue with it, but I've not done anything super complex either with it. So after I cut that, I still have this kind of weird gap in here. So very similar to what we were doing before is the delete face. Delete face works with surface bodies and with solid bodies. So same thing, if I hit just delete here, it's just going to totally blow a hole in here. We can kind of just look right through our model. If I choose the delete face and patch, it'll blow a hole through my model and cut it out, and then it'll extend all the surfaces to the natural extension and then patch it all up. So you get it maintains the original curvature and integrity of the surface that you're working with, faces that you're working with. Does that make sense, or any questions on that, or other inputs or comments? Okay. Moving right along. Okay, models that are not solid feature friendly. I can't take credit for this. This was drawn by somebody on the internet a long time ago. But imagine doing this in solid features. It'd just be crazy. I don't know that it'd even be possible. And notice the amount of sketches. So when I do teach surfacing and whatnot, I tend to stress the point and bring it home that sketching is unchanged. So everything you know about sketching, all your planes and sketch relations and everything is very consistent. But see everything that they overlaid here just for that paw. All those planes, all those sketches, all that meshing, and then this is 2 features. There's one loft, and oops, I was wrong. There's a loft for that body too. Let me try to find just what that paw is. So this is everything for that paw. Just for that one face, that one surface. And you can see, I mean, I'm not going to expand everything, but you can see if you were to look through all the features that he put in here, I don't even want to venture to guess how much time he spent on drawing Disney characters. Is this Disney? I don't even know. Scooby-Doo, whoever does that. But there's a lot of sketches and splines and planes and curves and just stuff. But this is something you would not do with solid features. I mean, this is just outside the realm of possible. So this is what surfacing is good for. And for the guys that do the fiberglass stuff, I'm sure you're in the same boat. You're designing stuff that you just can't do in solids. Yeah, I know. The comment is these sketches aren't defined. And again, I don't know the guy that did this. Or girl that did this. I wouldn't want to do this myself anyway. But they just use a lot of, and I think this is just a lot of freeform stuff where he just kind of kept dragging and dropping until it looked good, and then put it out on the internet to share, which I'm appreciative of because this is a really cool model. Takes quite a long time to rebuild too. I probably shouldn't have done that. But this is included, I mean, he put it on the internet for free distribution, so it's also included in my file set. So if you want to go download it, or I have it on the flash drives, like I said, you're welcome to dig through this and learn what you want to learn, because there is a lot in there. Reverse engineering. So everybody said they didn't really do any reverse engineering. Is anybody interested in knowing what it would look like or what's involved?
Sure.
All right. Do I have the time, Peggy?
Yeah.
Yeah? Okay.
Probably got about another 10 minutes-ish or so.
All right. Let me see what else I have in my... Yeah, we're pretty good. Okay. So real quick, this is a bottle. One of our customers does bottle fillers and stuff. So this is a bottle. I had to cut out the name to distribute it, so that's why that hole is there. But this is what scan data looks like. It's really ugly. You cannot CNC against this. You cannot work with this hardly at all. It's just super, super nasty geometry. I have 3 examples here, and this is kind of where the surfacing world really gets fun. But here's all the sketches used to create this geometry here. And basically, you take a plane and you put a sketch on that plane, and you do a bunch of intersection curves. Everybody's familiar with intersection curves? I'll just go delete some of this here. You pick faces. So notice how it picked that little squiggly there, which is the convert entity face split. It's somewhere in my PowerPoint, but I recommend use your selection filters if you're doing this type of work. With my selection filters, I can say I only want to pick a filter faces and not edges. And then no matter where I click on this, it's only going to pick the face, as opposed to if that's not on, you get like the little clicky of those, and it's really freaking annoying. So the faces only will save you a lot of time in that regard. I think you can even box select, but you often get more than you bargain for, but it's a thing. So you could box select stuff like that. And then if you click over here to convert entities, there's an intersection curve. Wherever any one of those faces touches that particular plane, it'll overlay a sketch in that instance. Now the sketches are not necessarily pretty. They're all converted splines, and it's not something you want to work with, but that's how you would convert a face in an intersection to a plane. After you do that, I shouldn't have done that. Anybody have any questions? So after you get a bunch of, and yeah, I messed up that model. Doesn't like it when you remove its geometry. So here's all of the planes and sketches used to convert that scan data geometry. And then I tried to duplicate this here with 2 different features, just to kind of give you an idea of how you might have to play with various features when you're doing free organic design like this. Let me try to change the color on this body. So here's a loft where I basically took, oh, whoops, I missed a part. Sorry. So then you take these sketches. So this is actually manually overlaid sketches. So I just took a bunch of arcs and laid them around the sketch that has a bunch of splines. So I'll try to make this really clear. I'll delete out some of this here in a minute. Sure. So here's the first sketch. First of all, never make sketches. If you convert a sketch, close that sketch out, start another one. Don't do any of your intersection spline sketching and then lay your good sketches on top of that. Totally never do that. Just telling you right now. So here's the original sketch that I converted off the scan data geometry. And then you overlay sketches on top of that, often splines or arcs and lines, avoid splines. And you just kind of try to get it to close, and it depends on your tolerance and that kind of stuff. This can be a really easy job or a miserable job. But once you overlay that, then you can delete your source sketch, or hide your source sketch here. And you end up with good sketches like this, which is good human-laid manual geometry that's decent to work with. And then you can overlay, and this is just a surface, or boundary surface. So I picked these 2 sketches here, that one, and then all of these direction to control curves basically wrapping around that extend that surface out. And we can kind of see, and again, it depends on what you're trying to do and how accurate you're trying to be, but you can kind of see how I matched the original scan data. Close-ish. What you kind of got to be careful with is when you're overlaying all these sketches, you're not always guaranteed to get good, clean models. And I played with this one for a little while and got it as best I could for a demo, but it still wasn't actually all that great. And if we look at our curvature, we can kind of see these really ugly red pulls in here. If I rotate the model, you can kind of see those crease lines, which would be really ugly if you went to manufacturing. Zebra stripes kind of helps with that too. So you can kind of see how you've got all these crease lines through here. So after I did the boundary surface example, I also put together a loft example. The loft example is weird because SOLIDWORKS doesn't like to loft to itself. So you can't like loft donuts sort of very well, maybe not really. So you just split it in half and you loft 2 sections and you knit them together. And so if we overlay the loft to our boundary surface, you can kind of see where this pole crease here is pronounced on both sides. But they're, for all intents and purposes, pretty close. So if we turn back on our original scan geometry and change our loft surface color. I thought I had colors on this last time, so I apologize for that. We can kind of see the bleed through and that we're pretty close to what we're trying to accomplish. So you just do that method or some iteration thereof 50 times, knit all this together, and you give the customer back a originally designed organic feature tree driven SOLIDWORKS model of any object in space that they decide to scan in with a 3D scanner. So this is really fun. I worked in this industry for a couple years doing scans, taking the point cloud, converting it to triangulated mesh and NURBing it, bringing it into SOLIDWORKS and reverse engineering it, and giving it to the customer so they can make minor tweaks or work and maintain a natural SOLIDWORKS feature tree. So that's fun times. I actually had a lot of fun doing that work. So here's the same thing I just did a little bit more. Turn off our sketches. But you can kind of see how did the bottom floor relief and started filleting around to make this bottle look quite similar to what the scan was. It would look like that. Again, all depends on your tolerance. I mean, this is plus or minus 10 or 15 thousandths, which for a plastic bottle is plenty good. They vary that much coming out of the blow molder. So here's the door handle design that I was referencing a lot. This is kind of more organic consumer product design. I did this in surfacing because I did this for a real job, but then I couldn't use the customer CAD data. So I just drew it up myself as an example of how to do organic design and then hacked it apart and used it for my own data repair examples. So self-sustaining loop there. But here's surfacing, and then again, your fillets are very consistent. They work the same way, like so. And then I thickened it, so kind of like sheet metal, thickened it out. And then did some more filleting back into there. And then put a boundary surface out here like that. And cut it apart. Did some trims to it, and then add in some ribs. By the way, the rib feature here, for anybody in the plastic design, I'm sure you guys know it, but this is the one time I tell my students it's okay to not fully define your sketches. Otherwise they get points off, but if you just draw a little line and do your rib command, super powerful. Love it. Some more extrudes and that kind of thing. Here's the move face example that somebody mentioned. Because this is why I love this model, but because this is tapered both directions for draw, it'd be very difficult to, I need this face like an 1/8 inch taller. This would be very difficult to pull off with 3D geometry because I'd have to like extrude with draft and then cut with draft and or like delete and trim and do a bunch of weird stuff. But I basically just want that taller because your keyhole has to stick through your door panel and get to your cylinder. So this is where your direct editing features is where they'd show up on the toolbar, but where, or 1/16 of an inch technically, but where your move face command works really well. You pick on a face and with a triad you just say move, and it will continue the trim and the knit, and it will continue your curve or maintain your curve and everything, and just move it around. So, and then when you click on it, oops, yep, and then you can just say. You can literally just do really awesome direct editing stuff. And you can see how we've got our tapers both directions because our diameter here is 449. And if I undo that, my diameter is 496. So that would be really hard to blend in with manual features. But you can just say move face and just move it out over there and it moves. I don't have a better example. I should get a better example. But once I was doing a dashboard for a motorhome where they do like the clay model mock-up, scan it in with a 3D scanner, and then give it to you and say like, model it. And so you got this whole dashboard with the instrument cluster and vents and your change pockets and stuff and all kinds of crazy stuff. And the change pocket, we originally drew it to the clay model, and then they made a vac form prototype. you're like, oh, that change pocket is way too far. Like when we're sitting in the seat, we couldn't reach it. So you need to take that change pocket, like, you know, just a 1-inch dip to store your cell phone or whatever, and move it closer towards the passenger, like 4 inches. We're like, okay. So you go into our model, and there's so much built on top of it that when we went to the original sketch and just moved it 4 inches, like everything blew up, which happens in surfacing. That's just a reality. So we just took the cheater way out, and we just said, pick all of those faces. I think we just basically right-clicked and said select tangency, and then Triad moved it 6 inches, and it just took it, moved it 6 inches, and like in one feature it was done. So the move face command is extremely powerful. I should probably come up with a better example and add to my presentation, but encourage you to leverage that if you ever run into that situation. I believe my very last example is C2.
Big timing.
Awesome. So this I also, this was on a SolidWorks blog not too long ago. I thought it was a good example, so I downloaded it, so I can't take credit. But this is a C2 example, scoop example, where this kind of this looks like just a revolve or a loft of some kind, and then just a cut with some fillets. But if we look at curvature, we can kind of see how the transition here is extremely smooth. So this would be like automotive C2 or C3 surfacing. And the only way to really pull this off without using surfacing is in 2015 or 16, I don't remember, they added in the fillet command conic row and conic radius or something like that. But basically here's your main surface, which was again a boundary surface. So we had these 3 sketches because they changed, this is at a tighter radius than that here. So they changed the direction of it as it went. And then they cut out the scoop and added in a sketch here that's going to define the, I think they cut that away, yeah, that's going to define the inside scoop. And then they did 3 different, forget the name now all of a sudden, 3 different boundary surfaces that linked, that blended this together, and they chose to do curvature to face, which will give a very nice conic row or conic radius blend between the faces, and then knit it all together. So we can kind of see, based if we look at evaluate and zebra stripes, how nice that looks. So if you're into that kind of thing, that's one way to pull it off with surfacing with admittedly a lot more features than what you would expect it to take. I believe that's all I have for sample models. Again, all of this is available on those flash drives or download should you want it. If you have any questions or anything else you want to add? Anything that I missed? Tip and trick that everybody should hear? All right. Thanks, everyone.